Hi, this is Tom Spring here with Ami Luttwak, the co-founder and CTO of Wiz, a cloud security company. Is that a good way to describe it?
Yeah. We are the cloud security
All right,
company.
we're here at Black Hat USA 2021, and we're here to talk about some research that you unveiled at a session here at Black Hat.
Yeah.
Do you want to introduce yourself a little bit, and then we
Sure.
can dive right into the research?
Sure. So first of all, it's really great to be here, and thank you for having me. So I'm the CTO for Wiz, and this research is done by the Wiz research team. So it's a group of highly experienced researchers, and our goal is to do groundbreaking research in cloud, basically find vulnerabilities, misconfigurations, attack paths that are unknown today for anyone and affect customers in the cloud. Basically, we're trying to break the cloud.
Break the cloud.
Yeah.
Okay. Well, that sounds like a lot of fun. Now, the research session that you did today here at Black Hat, it was called, help me out here,
Yeah, so it was a new class of DNS-as-Service vulnerabilities.
a new class of DNS vulnerabilities. And in terms of the vulnerability itself, can you describe what the vulnerability is? And,
Yeah.
and again, we're going to try to keep things very brief. We're going to try to give everybody the 10,000-foot overview. That wasn't a cloud pun. That was intentional. But we'll keep it light and brief in terms of the nature of the vulnerability. But I think the vulnerability is really interesting, and it's something that nobody else has found, and it sounds like it's very concerning.
So basically, we're looking at a service called DNS-as-a-Service. And it's one of the most important services that you use today in cloud, right? So companies are stopping to use the DNS servers on-premise, right? No one wants to manage DNS servers. And they're using DNS as a service. So for example, you host your domain, right? Usually you go to a DNS-as-a-Service provider to host your domain. Mm-hmm. So we explored Route 53, that is the AWS DNS-as-a-Service. But our study has implications on majority of DNS-as-Service providers.
So there are many DNS service providers that are also susceptible to this type of.
We actually believe the majority of them are susceptible. We did responsible disclosure with some of them, but we just we need the industry to also help us and explore this with other. Even after the talk, someone came to us. They said, "I'm actually now checking it out on another vendor, and I found the vulnerability." So it's like we believe this is like a wide vulnerability on the industry level.
So I'm gonna cut to the chase, and then we can work our way backwards. In terms of the security issue, that's what is it? What can this vulnerability do? What can it expose? What is the vulnerability? And then we can talk a little bit about how we got there.
Sounds good. So basically, to put it simply, we did a simple domain registration in one of the DNS-as-a-Service providers. And what happened was that we were able to get, we call it intelligence state-level capability. Basically, we got from all of the Windows endpoints of those companies, the computer names and their internal IP addresses and their external IP addresses of all of the computers and endpoints in those organizations. So I'm talking about like dozens of thousands of organizations and government agencies from after a few hours of just sniffing this to understand the impact of what we did. So from a company perspective, this means that we were able to map all of the external locations of the company, their internal IP ranges, the computer names of the company, right? And all of that without a trace because of this very unique vulnerability that we found.
So talk a little bit about what a hacker or a nation state or a criminal organization could do with that type of information.
Yeah, so that's a great question. So it's actually an intelligence database. Like we started asking questions, right? So I see all of the external locations of a company, right? So we show that there's like the different sanctions of places you're not supposed to be doing business with. We show that there's a mining company and we see endpoints from the Ivory Coast, right? Mm-hmm. Or there's a credit union company and we see endpoints from Iran. As an attacker, what I can do, if I have all of your external locations, this is amazing intelligence for me that I know what I want to start targeting. If I also have your IP ranges within and the computer names, gives me intelligence of exactly how your network is built, what systems you use. Because, in the computer name, I can see a lot of information about the company. This can come from internal networks that are supposed to be isolated, right? And again, without leaving a trace. And what we also found is some of the information that we found can actually be used for an initial infiltration vector, not only intelligence, right? So building maps of all organizations from an external perspective, internal perspective is amazing.
Okay. Well, now we can sort of dip back into where we started and talk a little bit about this type of vulnerability and how you came upon it and how it still remains a problem today.
So what are the causes of this vulnerability and how did we come? Basically, there's two causes to the vulnerability, right? The first one is that there is a protocol called dynamic DNS. This protocol is a protocol that was built 20 years ago for a very interesting and important cause to allow computers in a network to communicate. This protocol is not relevant for organizations today, should not be used outside of the organization. It's actually a security risk if it's being used outside of the organization because it holds a lot of sensitive data.
What was the practical application once upon a time ago?
So in the past, this was a very important protocol because it allows me, think about the company telephone book, right? So each computer, when it gets a new IP, goes to the telephone, the central telephone book, and updates, hey, here's my name, this is my new address, right? By doing that, it allows all of us to communicate, right? Yeah. Without dynamic DNS, it was impossible to communicate in an organizational network.
Okay.
So it was a critical protocol.
Okay. But now why is it obsolete?
If I'm now at home, I'm working from home, I don't need to update my computer name and IP. It's an internal IP in my home. You wouldn't be able to use it to communicate with me, right? I'm working remotely. It's actually sensitive information that I shouldn't want to share at all on the internet. So this protocol was not supposed to be built for the internet. So the information shouldn't be sent to the internet.
Yeah. Okay. So now the proof of concept that you guys created was based on dynamic DNS and its ability to do network discovery.
So I'll explain what happened.
Endpoint.
Right. So basically what happened was that most companies don't think about dynamic DNS in the context of internet, right? But what we found is that the algorithm still works. So if you are now at home or in a coffee shop, your computer doesn't know that. It still tries to find what is called the master DNS and update it with your location. Now, we found a way to register a specific domain on all of the DNS providers that makes the Windows computer believe we are the primary domain. So it means that computers believe we are the primary domain. They are sending us their computer names and their internal IPs, right? And if you think about it, this wasn't supposed to be active at all on the internet. So there's an old protocol that has, again, very important implication in the past. But on the internet, because of this specific vulnerability, it allows us to get all of that traffic.
But the traffic you had mentioned before is a mistake, and you shouldn't be getting this traffic.
Of course not.
And you were able to register the domain name server with your domain, which could be any domain that you would perhaps want to honeypot or to create a target of in terms of a threat actor.
Right. So the problem we're seeing here, right? The problem of it has several factors and several reasons. One reason is that those computers are still using dynamic DNS and sending traffic. The other reason is that how can we grab all of that traffic? So what we did is basically leverage the fact that DNS service providers allow you to register domains that you don't own, right? And we found a specific domain that if you register on it, because of the specific algorithm that those endpoints use, it causes them to think we are the master domain, right? So we are leveraging something.
When you say a specific domain, I think you refer to it as a magic domain.
Yeah. So,
but now, can you give me an example?
Yes.
And why is it magic?
Yes, I can. So basically, it's just a trick that we found. Basically, DNS works with something called name servers. Name servers are they have the wisdom. They know you go to the name server and you ask for a specific domain and they give you the answer, right? So we thought, what would happen if we go to the name server and we register on that name server its own name?
Yeah. Yeah.
So that's what we did. We went through 2,000 name servers in AWS and we registered their own name on themselves. And again, shouldn't have any impact, but due to the specific algorithm that these machines have, because of like 20 years ago, maybe there was some logic in it, it causes the Windows endpoints to send traffic to us.
Mm-hmm. Now, I'm sorry for asking a rudimentary question. The flaw, where is the flaw? Is it in the DNS or is it in the client?
No.
Or?
You're actually asking one of the most interesting questions here, because the flaw is in the international waters.
Is in the what?
It's international waters. Basically, what I call this international waters because no one owns this.
Oh, international waters.
Yeah, because it's like, DNS is a protocol between a client and a server, right? The problem that we found, you can say it's the Windows endpoint fault. You can say it's the DNS provider fault. And you can say the customer is responsible because they didn't configure it correctly. So when we talked with Microsoft, they said it's not a vulnerability. The customer didn't configure it correctly, right?
So the sysadmin did not configure his network correctly.
Exactly.
To where it's reaching out to the wrong DNS server.
Yes, but there's a caveat here. There is no sysadmin in the world that knows they need to configure that, because I'll explain why. Sysadmins control internal DNS. Mm-hmm. In most companies, the external DNS is managed not by the sysadmin, but someone else. But what we found is that the misconfiguration was the external DNS. Sysadmins don't even know that computers at home go to the external DNS, not to the internal DNS, right? Mm-hmm. So you can say it's the sysadmin's fault, but only if they listen to this talk and now they know they have to configure this also on the external DNS.
Well, I know this is very complicated stuff, and I know that you have a very excellent blog that is going to break it down. But I do want to keep things short here, and maybe you can tell me a little bit about what people are doing to solve this problem and what people can do to mitigate this issue. And I know that you mentioned what Microsoft had said to you in terms of the issue. I don't know if Amazon Web Services has weighed in or
you're right. So there's two different questions. First of all, what do I do as a customer to solve it? And the other is, what do I do as a DNS provider, right? So AWS solved it like within 2 weeks, and they basically blocked the ability to register our magic domain. So they blocked it. But from a customer perspective, what you need to do is basically, first of all, be aware that DNS and dynamic DNS is a risk, and you have to go to your public registered domain, not your internal domain, your public registered domain, and configure a specific record there that will point to your real primary server. So it's a configuration all sysadmins need to do. They have to go to all of their name servers that are public name servers of their domain, right? If you have like your own domain has probably 4 name servers, those name servers need to be configured to answer the correct answer when the computer asks, who is my primary domain? That's what every company needs to do.
And so this is not something that can be magically reconfigured by the international community or the sort of the DNS people and the client people. It has to be done by people who are configuring their own.
I would say the following. I think that it's because that's why I say it's international waters. I think everyone needs to fix it. So I think that the customers need to be aware of it. I personally think that Microsoft needs to consider to change the algorithm, right? Because if we saw 15,000 organizations are susceptible, it probably means 100%, right?
Yeah.
And I also think DNS service providers need to change the way they do it. They don't do enough validation on the domains they allow to register. So actually, everyone needs to be better.
So some of the big guys know about this problem. Some of the other smaller DNS
Exactly.
providers do not know about this problem.
Until this video. Now they will know.
Okay, but this is an issue that needs to be addressed industry-wide and creates a vulnerability for companies that want to keep the tight ship in terms of location of their customers, their offices, and much more.
Exactly.
Well, listen, thank you so much for joining us here at Black Hat, or joining us here on this video. I hope you have a great rest of your show.
Thank you.
All right.